A little bit about solution stoichiometry. The concentration of a solution is how much solute you've got for a given quantity of solvent or solution. And really the only one we need to know for AP chemistry is molarity. Molarity is capital M and it's defined as the moles of your solute, which by definition is the minor component in the solution. And it needs to be a homogeneous mixture, otherwise it's not a solution, per liter of solution. The moles, on the other hand, is the grams divided by the molar mass. Now that might be a little bit confusing, but for example, 18 grams of water is a mole. If you've got 9 grams, you've got half a mole, right? 9 grams of solute. Molar mass is 18 grams per mole. That kicks out as half a mole of solute. So let's do a problem. You got 100.5 ml solution, a little bit more than 1/10 of a liter. And it's got about 5 grams of a sugar, in this case glucose, in it. What's the molarity, capital M, of that solution? Well, molarity, why don't we write the definition? It's moles per liter. So on the bottom we need liters. That'll be 0.1005, right? On the top we have 5.1 180ths of a mole. Well less than 1/10 of a mole. So we just write all that down. There is your moles. Since it's grams per mole, right? It's a very low number. There's your liters, punch it in. The molarity of that solution is 0.282 molar. As a general rule of thumb, you can consider anything less than 1 molar to be a dilute solution, anything greater than that to be relatively concentrated, and that's a very rough guide, but at least it gives you something to rely on. That's a little bit on solution stoichiometry. Let's do 2 more examples. How many grams of potassium dichromate are required to prepare a 250 ml solution whose concentration is 2.16 moles per liter? Well, let's figure out how many moles and then convert it to grams, right? We're going to do 2.16 moles per liter times 0.250 liters. That's how much we have. And then we can convert the moles to grams since, it's not given to you. You'd have to add up the 2 potassiums, the 2 chromates, and the 2 chromiums, and the 7 oxygens. But let's go ahead and do it. You can do it all in one line. Doesn't matter what order you do it. You can start with what you're given. We have 0.25 liters of solution, quarter of a liter. And it is at that concentration, 2.16 moles per liter. Notice the liters of solution cancels. And if you do add up the molar mass of potassium chromate, you'll see that it's 294.2. And therefore, that shows you how many moles you're using. And this converts from moles to grams. And it turns out you better take 159 grams of potassium chromate. If you're going to make that solution, then you dilute it to 250 mils using water. And that's the next question. Take and dilute. Take your solute, dilute it to 250 mils using water. Here's another problem. In a biochemical assay, a chemist needs to add 3.81 grams of glucose to a reaction mixture. But he doesn't want to add pure glucose. He wants to know how many milliliters of a 2.53 molar solution they should use in the addition. Now, if you started with the 2.5 moles per liter and then tried to cancel your units, you'll find that you're upside down. You'll have to do 1 liter is equivalent to 2.5 moles, and it's not uncommon for you to start that way and get your figures inverted. So you just flip it over and you should be fine. If you start with your 3.81 grams and then convert it to moles, it's a very small fraction of a mole. And then figure out how, based on the fact that it's a 2.53 mole solution, molar solution, we now have liters of solution that you'll need. But they asked for milliliters, so we'll multiply it by 1,000. And it turns out you need 8.36 mils of a solution. If you were nervous about that answer, you could then calculate from 8.36 mLs of a 2.53 molar solution, and you should see that has 3.81 grams of glucose in it. So that would be a nice way to double check it. Okay, you should be in a position that you could prepare any type of solution at this point. And if you're in my classroom, you would be at this point asked to prepare lots of fixed molarity solutions, just to make sure you know how to do it. This is preparing solutions.